There are 4 different types of angles we're going to deal with inside circles or around circles, involving circles. 4 different types of angles. These notes are to take care of 2 of 4. The first one is a central angle. You've already taken notes on it, so this part should be a little bit of review. A central angle is an angle inside of a circle that has the vertex on the center of a circle. So not all angles that are inside the circle are central angles, just the ones whose vertex is inside the circle. Whenever you draw a central angle in the circle, you actually have 2 angles. One angle is the smaller angle that's created, the one that's smaller than a semicircle, or it could be a semicircle itself, and the second angle is larger than 180 degrees in this case. The section of the circle that the angle crosses is called the intercepted arc. So this part right here is an arc. The measure of the intercepted arc of a central angle is equal to the measure of the angle. So this is angle equals arc. If the angle equals 110 degrees, the arc equals 110 degrees. The diameter creates a central angle that measures 180 degrees. Okay? The diameter looks like a straight line. So the straight line is 180 degrees, then the intercepted arc is 180 degrees, also known as a semicircle. The new type of angle that you're learning about now is inscribed angles. This is an angle that crosses all the way across the circle and the vertex lies on the circle itself. So this is an example of an inscribed angle. It only creates one angle in the circle as it cuts all the way across the circle. It also intercepts the arc. The arc is still called the intercepted arc, and in fact every time an angle intercepts an arc, it's the intercepted arc. The measure of the intercepted arc is twice the measure of the inscribed angle. So if you have an inscribed angle of 30 degrees, the arc, which is across the circle, is 2 times the measure of the angle, so the arc is 60 degrees. So the formula for this is angle equals arc divided by 2, or angle equals arc divided by 2 symbolically like this. You could also say that the arc equals the angle times 2. Either way. Now, if you have 2 inscribed angles that are separate angles, but they intercept the exact same arc, the angles are going to be congruent. So if you started with 55 degrees for the blue angle, you had to multiply that times 2 to get out to your arc of 110 degrees. But then that arc intercepts the green angle as well, so I divide by 2 to get back to this angle, and you end up with the exact same angle. So if you're only given the blue angle measure, you can find the arc measure and the green angle measure in this case. Lastly, the relationship between the central angle and an inscribed angle is such that the inscribed angle is half the measure of the central angle. Think of it this way. If you have an angle that's 112 degrees and you take that vertex and pull it back twice the distance away from that arc, it's that measure divided by 2 to get you back to your inscribed angle. So if 112 is your central angle, well, we know that's the same measure of the arc, and then to get from arc to inscribed angle, we would divide by 2. So to go from 112 to your inscribed angle, it would be 56 degrees.